Hello everyone, I am Uday Kumar, doing my third year BTech in NIT Andhra Pradesh, and I am from EC department. In this video, I am going to discuss and solve the automation of frequency modulation using linear programming problem. Basically, this is from automation techniques course, and these are the contents: introduction, frequency modulation, objective and solution, application and advantages, and finally the conclusion. Introduction: frequency modulation is a widely used technique in communication system to transport information through radio waves. However, the efficiency of FM can be improved by optimizing the parameters involved in this process. Basically, I am going to improve the parameters of SNR of a frequency modulation to get a efficient solution in the feasible region. In this automation presentation, we will discuss the use of simplex algorithm. We will also demonstrate how Python can be used to implement the automation process. Frequency modulation is nothing but frequency of carrier signal changes with respect to modulating signal. In this slide, we can see that the frequency of carrier waveform is being changed with respect to modulating signal, and the third figure shows the frequency modulated signal. In automation techniques, linear programming problem involves maximizing or minimizing a linear objective function to linear constraints. In this context of automation from modulation, the objective function would be the efficiency of the process and the constraint would be the limitations on the parameters involved. Next, this is the objective function by which we are going to solve this problem. Objective automation of frequency modulation using LPP by minimizing SNR. SNR involves noise. SNR is nothing but signal to noise ratio, by which we are increasing signal and decreasing noise. That is nothing but minimizing the SNR. Solution: objective function is to the optimization of FM using LPP considering SNR involves the minimizing the transmitted signal power while minimizing the noise power. Maximizing the transmitted signal power involves PT minus PN, where PT is transmitted signal power, PN is noise power. The constraints are Pn is less than or equal to Pn by SNR, Fmax minus Fmin is less than or equal to B, Fdv is equal to Kf into Vm. As mentioned here, the first constraint ensures that the noise power is less than or equal to the single signal power divided by the SNR. The second constraint limits the maximum frequency deviation to the bandwidth of the channel. The third constraint relates the frequency deviation to the modulating signal voltage using the frequency sensitivity. These are the full forms of the above given parameters, constraints, and objective function. The applications of frequency modulation. Frequency modulation is widely used for FM radio broadcasting. It offers a great advantage in radio transmission as it has a large signal to noise ratio, meaning it results in low radio frequency interferences. And the advantages are given below. Less radiated power, smaller geographical interference between neighbor stations, well-defined service areas for given transmitted power, improved signal to noise ratio with respect to man-made interferences. And this is the conclusion. By using Python implementation, the automation process, we can take advantages of its ease of use and powerful approach to quickly and efficiently find the automation solution. And that's it. And next we are going to discuss about the code in Python and implement it to get the feasible solution. This is the code in Python to maximize SNR and get a feasible solution. First, input the bulb from libraries and take input from the users for the required parameters. such as bandwidth, f-senses, frequency, VM, SNR, and create a maximization problem instance. And define decision variables, define objective function, define constraints, and solve the problem. Print the status of the solution, if it is feasible or optimal or not an optimal solution. And if it is in feasible region, we will get an optimal solution. We will execute it. Now we will execute it. I am taking bandwidth 100 kHz, frequency sensitivity 5, modulate the signal to voltage, and the signal to noise ratio 20. And the status is showing that the solution is optimal, and the optimal frequency deviation is 10 kHz. Optimal transistor signal power is 0.4040. That's it from this video. Thank you.